Welcome back. Until now, we have seen what happens if you have a central atom in which there are two atoms around it. Sometimes the atom had two lone pair of electrons, so it made the V-shaped or the nonlinear shaped or the band shape. And when there were no lone pair of electrons, that one was directly straight, 100% straight. Nothing to decrease the repulsion. The repulsion is equally done from both sides. If I have one central atom and three atoms around it, so there is one atom, one atom, one atom. So there is three types of bonding pairs. This is a bonding pair between this A and X, and this one also. This central atom has no lone pair of electrons around it. So the repulsion is only between the bonding pairs. What happens? These bonding pairs will try to distribute themselves so they get far from each other as much as possible. No, that's not enough. Let's delete one from this and try to put it a little bit more far. That's still not enough. Still not enough. The only way that this can be distributed so they take a shape that the repulsion is equal from all directions so that they stop fighting with each other, minimize the fight with each other, is to have these Mercedes-shaped lines. So if you imagine that this is the central atom here, and there are three atoms around it, let's say it's X. What is X? X is standing for any element. So if I have B, this is the boron, and it has three fluorine atoms around it. The only way that these bonding pairs are going to stop fighting with each other by minimizing the fight, so this is fighting with this one, and this is fighting, repelling from this one, and this is repelling from this one. If you try to move one of these a little bit to the up or the down, then this angle is going to be less, and the repulsion here is going to be too much. So you have to decrease the repulsion by making this exact three angles. But what is the angle here? The total angle was 360. Remember the last time we divided by 2 and got 180? So this time, I know you know the answer. Now you need to divide this by 3. When you divide the 360 by 3, you get 120-degree angles. So 120, 120, and 120 degrees. Please take care that this is called a trigonal planar. A trigonal because it takes the shape of triangles. So there's like a triangle here, and there is one triangle here, and there is one triangle here. So it takes the shape of triangle. I forgot about this shape and why it's called like that. I just need you to make sure that it's called planar. Planar means these three bonds are all available in the same plane. So it is a 2D shape. It's not a 3D shape. Please take care because some books and some websites, they put marks showing that this is a 3D shape. It is a 2D shape because these all are on the same plan. That's why it's called a planar. So if you want to draw this on a piece of paper, then you will draw it like that. Nothing is going to stick out or in from this one. So this is the paper will be enough to draw your picture on it because it's a 2D shape. The angle is 120 and the shape is trigonal planar. This happens when there is a central atom and the central atom has three atoms around it and there are no lone pair of electrons in between. Remember to compare this to the linear and the nonlinear or the band shape. What happens if we try to incorporate a lone pair of electrons here? Like instead of having the central atom without nothing but bonding pairs, so this is one bonding pair, this is 2, and this is 3, we'll see another molecule in which there is 2 electrons sitting here. And we have just seen this molecule recently. This is the nitrogen atom. The nitrogen atom is in group 5, so it has 5 valence electrons. Remember that the number of valence electrons are known from the group number. Nitrogen lies in group 5, so the outermost shell has 5 electrons. It uses one of its electrons here to make a bond with this hydrogen, and one more electron to make a bond with this hydrogen, and one more electron to make a bond with this hydrogen, and that's it. There is no more atoms to join, so we cannot join these 2 electrons with anything else. Now let's have a look at the repulsion. The repulsion between there is only one lone pair of electrons, not 2 like the water molecule, but still the repulsion between this lone pair and this bond pair and this lone pair and bond pair is much stronger than anything between these 2. So if you got asked in the exam, why does the molecule takes this shape, you have to explain it like that. Please listen to me. The repulsion between the lone pair and the bond pair, and this lone pair and bond pair. It will be great if you draw it. Is much more stronger than the repulsion between this bond pair and bond pairs. You see the bond pair, here is a bond pair, and here is another one. And this is also a repulsion between a bond pair and bond pair. So this is much weaker than the strength of these strong ones. Remember, we said the repulsion between bond pair and lone pair and bond pair, and lone pair and bond pair is much stronger than the repulsion between bond pair and bond pair. So what happens here? The shape is no longer trigonal planar. It's gonna take a different shape. This is the shape of the molecule. This is a 3D shape. The 3D shape of the molecule is what's looking like the pyramids. So let's imagine that nitrogen is sitting at the top of the pyramid here, and there are 3 hydrogen atoms sitting here at the corners of this pyramid. And this is the lone pair that caused all the dilemma. So the shape now is pyramidal, it's no longer trigonal planar. And the angles cannot be 120 like before because somebody has pushed these angles too much. You cannot divide the 360 by 120. This shape even will not be correct now because after we put the lone pair, these molecules have to move a little bit to make place for these repulsing electrons. So if we draw it from the side, it will be like that, and then it's going to be like that. This is the only way that we draw it, and it shows that the repulsion is very strong, like from these guys, these repelling guys. So what will be the angle now? The angle now will be 107 degrees. This is the only type that's going to make the repulsion minimal. But as you see, this shape is a 3D shape, and it's not a planar shape like the trigonal planar. So what is the way that I can draw this in a correct way to show the person who is looking at that this molecule is not a 2D shape? You cannot just draw it on a plain piece of paper and expect everybody to understand. And you cannot keep drawing pyramids like that if you are bad at drawing like me. So the chemist has came up with some tricky way to draw a 3D shape without actually drawing it. Let's imagine that I have this nitrogen atom here, and then I will draw one H atom here. This is a normal H, which shows that this atom actually is just on the same plane. So if you are drawing this on a piece of paper, and let me draw this piece of paper again. This is my piece of paper, and you are looking at it like that. So this is my book, and this is my piece of paper. So this is a nitrogen atom. Let's make it a little bit smaller, so it's like that. And this H is sitting like that. So it's in the same plane. It's on the same piece of paper. But I want to show him that this is something which is sticking out from the page. So if you are looking from the side to this book, this is my book, and I'm looking from the side view. So I'm not anymore looking like that. This is the side view that we're looking. Now I'm looking from here. So imagine that you are standing like that, and you are looking here. Here you are with your arms, and this is your back, and this is your hair. You are looking to it like that. So this is the book, and this is the paper. Now you cannot see the nitrogen. Why? Because it is here. You can imagine that you are looking to it, and this is the book. So the nitrogen is sitting here. This is the hydrogen. It's on the same plane, so you don't see it. Now I want to show something that's sticking out of the paper. So there is a hydrogen atom which is sticking out of the paper. How can I draw this here on this piece of paper? I'll draw one black triangle like that, a small black triangle which tells the person who is looking that this is sticking up in his face. So if you are looking at it from here, then it's coming towards you. If you are looking to it from the side, it's coming out like that. Then how do I tell him that there is something going to the back side? So it is out of the plane again. This is out of the plane and coming to the back side like that. There is one more hydrogen. So I'll draw this dashed line. This dashed line will tell the person who is looking that there is one hydrogen atom again here, which is coming to the back side. So again, if you are looking at me, there is one hydrogen which is on the same plane, one hydrogen which is coming, sticking up, and one which is going to the back side. So this is the hydrogen, something that's going to come up here. That's what we draw like a black triangle. And from the back side, there is one hydrogen atom. I'm not going to call this trigonal planar. It's not on the same plane anymore. I said that once you have a central atom with 3 different atoms around it, and you have one lone pair of electrons, you are going to call this a pyramidal shape. And we have agreed already about the angle that is going to be 107 degrees. Hey, mister, until now you didn't tell me the angle of the water molecule. Remember, the nonlinear one, or the one we called bent. The angle here is 104.5. Just pardon me for the strange angles. I'm gonna tell you how you can memorize this carefully in a good way later. That was the nonlinear, which we called bent or V-shaped. That's different because the angle was 104.5. Here it was 107. This is still linear here. Yes, it's still linear here. What does it mean? I didn't mean it's linear. I mean it's planar, but it is nonlinear. It is bent. Some people call it bent. Please follow the name on the syllabus and always write nonlinear. I'm gonna add the two electrons here to make this looks correct on all our drawings.